Welcome to Press Grid. This is Network and Security Job Oriented Training, day 6. Today we are going to discuss the limitation of the subnetting and VLSM. So it's very important, this concept. So now we previously we discussed what is IP addressing, subnetting, right? How to do subnetting. And today, problem with the conventional classful IP addressing. We discuss about the classful IP address, class A, B, C, D, E, right? So only class A, B, and C are being used, right? And now, what is the issue with the problem with the conventional classful IP addressing? The wastage of IP addresses due to the rigid IP class structure, right? So we have a structure class A, class B, class C. Those are not flexible enough. So subnet mask gives only one additional level of hierarchy. Within a subnet, fixed number of hosts are available depending on the subnet mask. And example, limitation on router table entries as more and more hosts and subnets are getting connected. So exhaustion of the class B IP network addresses. Example, organization requested class B addresses even though class C address would have been enough. So let's take a look here in the next slide. Subnetting, right? We already discussed the subnetting. What is the subnetting? A bigger network is divided into various smaller networks for internal use within an organization, while for external world it is treated as a single network. And you already know this is the formula, how to do number of subnets. We discussed it, right? If you borrow 3 bits, you can equally divide that network 2 raised to power 3 minus 2 is equal to 6 network. So let's take an example here. Again, subnetting. You already know subnetting, but subnetting as a large network is logically or physically divided into multiple small networks or subnets. That's called subnets. Why we are doing it again for? The reason for subnetting a large network is to address network congestion and its negative impact on speed and productivity. In other words, to improvise the performance. Okay. And illustration of subnetting limitations, right? So let's talk about what are the limitation of subnetting here. So this is an example. Consider class C network IP address 20.1.45.222.0. This is the IP addresses. Now assume that network administrator requires 6 subnet as below. So network admin says, hey, I need the 6 subnets, subnet 1, 2, 3, and 4 with the 10 hosts each, and subnet 5 and 6. 5 we need with 50 hosts, and subnet 6 we need a 100 hosts. So total number of hosts are 190. So 1/24 subnet is enough, right? Because this one has already enough IP addressing. Slash 24, how many slash 24 can have? 2 raised to power 8 minus 2, right? So it's 254 IPs you can have it for host. So slash 24 subnet is good enough. But if you want to create a subnet in a traditional subnetting way, if you borrow 3 bits, right, you can have 6 subnets, 2 raised to power 3 minus 2. So then you can have 6 subnets, but all 6 subnets will have the same host. So you are equally dividing into, let's say this is a slash 24, and you're equally dividing, right? You can see here 1, 2, 3, 4, 5, 6, 7, right? 8. You're equally dividing this into slash 27's network. But that's the traditional way to do it, right? Now, our requirement is we want to create subnets and that has a different host requirements. So first subnet 1, 2, 3, 4 has a 10 host requirements, and subnet 5 and 6 has a different host. Subnet 5 has a 50 and subnet 6 has a 60 host. So this is the requirements, right? And let's take a look how we can address this issue. The solution is variable length subnet mask. So what is variable length subnet mask? The idea is that we subnet the network. So we subnet the network and then subnet the subnets, right? So we first subnet the network and then subnet the subnets just the way we originally subnetted the network. So this can be done multiple times, creating subnets of subnets as many times as we needed, depending on the number of bits available in the host ID. You remember, right? When we want to do subnetting, we borrow a bit from the host ID. This concept of multi-level splitting can be applied to selected address blocks, thus creating uneven size of the blocks as per requirement. It is complex due to multi-level of subnetting hierarchy, but let's take an example. It's very easy. You can easily do it. So VLSM, variable length subnet mask. Now again we have the same requirements. We just talked about it, right? We did subnetting in a traditional way, but now we will apply variable length subnet mask approach. And this is how we can provide the solution. So 20.201.45.222.0, this is our IP address. This is /24 IP addresses. This is the class C IP addresses. Now we want to divide how many subnets we need total? We need total 6 subnets, right? 4 subnets with the 10 host and 1 subnet with the 50 and 1 subnet with the 100 host. So let's do it. So this is our IP addresses, right? If I convert this into binary, this is the value. You already know how to convert binary, right? So 0 means all zeros. You already know, right? How we come up with the 2 to this value? If you still recall it, right? 1, 2, 4, 8, 16, 32, 64, and 128. So we do 1, 1. This value will come around 192. And then 192 plus 16 plus 8 plus 4 and plus 2. That's our 122. And how we come up with the 45? You already know. This is the same formula we use it, right? And this is the binary value. And now we borrow 1 bit from the host part, right? What is our first step for variable length subnet mask? How we do it? We just borrow 1 bit. You see here in the blue, so we borrow only 1 bit from the host. Because again, this is a /24 subnet, right? So this is our network ID. We don't touch this. This is our network ID. And this is our host ID /24. So in host ID, how many bits we have? We have 8 bits, right? So we borrow 1 bit from this host ID. And what happens? When you borrow 1 bits, you divide basically this network into 2 parts, right? This is 201.45.222.0 /25. Here it was a /24 network, but when you borrow 1 bits, you divide into two network subnets, and your original network become the smaller one. So in this one, you can have maximum 254 host. Now you divide into half, right? So how many you can have in each? This one, 126 host, right? So in this one you can have 126, and in this one you can have 126. Because originally our host is /24, that's mean you can have 254 host in this /24 network, but now we equally divide it into two by borrowing 1 bit. So that means we are dividing into two, and now you can have 126 hosts in each subnet. Remember, when you do subnetting, you always make it a smaller network, right? So when you borrow one bit, you are equally dividing into two. So this one can have 126 and this one can have 126. Now this will address our for one subnet. If you see here, what's our requirement? Subnet 6 with 100 bits, right? So this one can have 126 bits, right? So if you further divide 126 into half, then it's become the smaller network, right? 126 divided by 2, what will become? Will will divide into less, right? So now you want to keep one subnet as this one because it meets your requirement for subnet number 6. So we set aside this first subnet as a for S6, subnet number 6. So this is our subnet number 6 for our 100 host, right? This will apply to 100 host, and rest 26 host, it's wastage, but it's okay because it meets our requirement. And now let's talk about here. This one has a still 126 host, but in this 126 host, we need to address 50 and four more subnets, right? And each subnets will have a 10 host. So let's borrow one more bit from this one. So remember, what is our subnet mask here? 255.255.255.128, our subnet mask. So we borrow one more bit here. Our subnet mask is a slash here slash 25, and you borrow one more bit. Which one is this one? 0. So we divide further our 201.45.222.128 slash 25 network into two more subnets by borrowing one more bit. This is we are borrowing now seventh bit, right? This is the seventh bit. And what happened? So one will remain this the same, right? 201.45.222.128 slash 26 and 201.45.222.192 slash 26. So now 25 becomes 26. Why? Because we divided into two more subnets. We borrowed one more bit and divided. So that's why it's become slash 26. When the slash 26 number increase, that's mean the network becomes smaller and smaller. Slash 24 can have 254 hosts. Slash 25 can have 126 hosts. Slash 26 will have 62 hosts, right? So if our slash 26 number increase, that's mean host number decreasing. And this is our binary conversion. And we set aside the second subnet as a subnet number 5. Why? Because this can have 62 hosts, right? So 62 hosts can address easily 50 hosts, right? So that's why let's put this one aside. We don't need to further divide this one into two. You can, if you have more requirements and if you want to split into two, you can do it easily. You can split into two more subnets as well. Now, what is our requirement here? 62 host, right? This one has a 62 host. So if you divide into four equal subnets, that's mean easily we can address subnet. Our requirement is we need four subnets and each subnets need a 10 host, right? So subnet 1, 2, 3, 4 with a 10 host each. So if you divide this one equally with the 4, then it will meet our requirement, right? So what you do, we further borrow two more bits, this 20, right? We borrow it and equally divide into, when you borrow two more or two bits, How many subnets we can create? Four. So we divide further our 201.45.222.192/26 into four subnetworks, right? By borrowing two more bits from the 6 bits left in the host ID, right? So how many bits will left? Sorry, it's 4 bits. And your network will become /28. And /28, how many hosts you can have it? 14. /27, you can have it 32, and /28, you can have it 14 host. So this meets our requirement, right? Now we created four equal subnets. 201.45.222.192. This is one subnet. This is second. This is third and fourth. This is we meet our requirement. So this is how we create 6 subnets from one network. And you see, right? This one has a different IP addresses and this one has a different and this all has a different. But again, remember in this, right? Here, what is our gateway IP address? If I talk gateway in this one, 201.45.222.1/25. This is our gateway IP. And what is the broadcast here? 201.45.222.127. This is our broadcast IP. Why? Because 128 start in another subnet, right? So 127 is our last IP. So this last IP always reserved for broadcast. And first IP we always use it for gateway. And if we talk about this one, what is our subnet mask? The gateway. In this one, in this subnet, our gateway would be 120.45.222.128. We can use it as a gateway because it's not zero, right? And our broadcast would be 255. But we divide it into two more subnets here. So now here our gateway would be in this subnet mask. Just writing GW. Gateway would be 201.45.222.128. This is our gateway. And what is the broadcast IP? 201.45.222.191/26. This is /26. This is our broadcast. And again, this one we divided into four more subnets, right? So for this one, what is our gateway? 192. Broadcast -1 here. So broadcast is 207. I'm just talking about the last digit only. So 201.45.222.192 is the gateway. 201.45.222.207 is our broadcast IP address. So this is our broadcast. And for this one, 208 is a gateway and broadcast IP is 201.45.222.223 is our broadcast IP. And in this subnet, 241.40 becomes the gateway and 255 will become the broadcast IP address, but /28 network. Okay. So similar example, right? Let's take it in a different picture. Now you saw the previous IP address /24 network. /24 we divide into two. So this is the /24, right? We divide into two hosts here. So one can have 120 hosts, but -2 means 126. gateway IP, and broadcast, right? So we divided equally into two. So this side will have 128 and this side will have 128. But then we divide the right hand side subnet into furthermore, right? You make it again subnetted here. This is so this will become the 64 but minus 2 gateway and broadcast. So you will have 62 host and this will have a 14 host each. Okay, this is another level of looking at the same concept. And now let's take it one more different way to how the same example I'm talking about it. Again, this is the same example 201.45.222.0. This is our original network slash 24. In original network, how many hosts we can have it? 254. So first division, we split slash 24 network into two by borrowing the one host ID. So this one has a 8 bit, right? So 201 is from 0 to 8, right? 45, this is our 16, and 222, this is our original network ID slash 24. This is our original network ID. You cannot change this. You cannot borrow it bit from network ID. You always borrow a bit from the host ID. So our original host ID is 8 bit, right? And then you borrowed one bit. And now your host ID will shorten, right? You will have 7 bit. Sorry, I think I just clicked on button and so 201.45.222 and you borrow one bit here. So this will become 126 host and this will become 126. So when you borrow one bit, you divide into two, 0 and 1. So this one will meet your requirement, subnet number 6, right? And that meets your 100 host. So subnet 6 will require 100 hosts. So that meets our requirement. So we are good. Now we are going to further divide in this into two more subnets. So we borrow one more bit here, right? Second division, split 1201.45.222.128. This is the slash 25 into two more. Uh, so that will become, we will have two slash 22, 26 subnetworks. And each will have 62 hosts, right? So this will meet our second requirement, right? This the subnet number 5 because subnet 5 needed 50 hosts. So you can this subnets can easily accommodate 50 hosts. And now again we are dividing this into four more subnetworks because we are borrowing two more bits. So when you borrow one more bit here, so again remember originally your slash 25 was your network ID, but after borrowing this one more bit, your become network ID becomes slash 26 here. But now you are dividing, you are borrowing two more bits. So 24 and the 4 means slash 28. 14 host, 14 and 14 and 14. Now you have equally divided. Further, if you want more, you can further any of the subnets you can divide into it, right? Even if you want to divide this one into smaller subnetworks, you can do it. This one you can do it. Till what time you can do it? Slash 29 slash 30 or slash 32 you can't do it because then you have no IP left for broadcast and gateway. So you cannot assign any IPs. Similar way slash 31 you can't assign any IPs to